Welcome back to the webcast of Rocket Lab Electron's second launch, still testing, from the Mahia Peninsula, New Zealand. I'm Daniel Gillies, and we're broadcasting live from the Rocket Lab Mission Control Center in Auckland. During yesterday's launch attempt, after we entered the auto sequence, 2 rogue vessels were detected in our exclusion area, resulting in a hold to be called to the launch countdown. When a hold is called during the auto sequence, it results in an end to the launch countdown. Although the vehicle was recycled for launch, the boats took longer than expected to be cleared, and combined with weather conditions, we ran up against the end of our launch window. As of right now, there are no rogue vessels downrange. Today, the outlook for weather throughout the window has high upper-level winds, posing a constraint for launch. However, the current conditions, while close to the limits, are go. However, they are still closely being monitored. We'll be counting down until just prior to the start of the auto sequence for a final go, and then we'll make a decision on proceeding with the current count or picking up in an hour-long window that will open approximately 10 minutes later. As always, in the event that we do encounter any issues during the launch, Rocket Lab will end the webcast while our team works through the data, and any updates will be provided via our website and social media stream. As you can see, the strong back retraction has begun, which will be completed here shortly, and we are approximately 11 minutes and 24 seconds until launch. Today's launch from Launch Complex 1 will take Electron on a trajectory to an 83-degree inclination, 300 by 500 kilometer injection orbit. The mission plan calls for deploying payloads from Planet Inspire Global, adding to their spacecraft constellations. The Planet payload, named Dove Pioneer, will perform Earth observation and is a nod to the Pioneer missions of the mid-20th century, and the fact that this represents the first spacecraft of many from Planet planned to be flown aboard Electron. The 2 Spire Lemur 2 spacecraft, Lemur 2 Tallham ATC and Lemur 2 Marshall, will add to Spire's constellation, further enhancing their weather and ship tracking datasets. Together, both of these customers share a common goal with Rocket Lab of improving life here on Earth. Electron stands apart from other launch vehicles operating today in its class, in that it represents an entirely new class of launch vehicle for small spacecraft. Traditionally, small spacecraft have had to ride share on large rockets, sometimes requiring compromise on where they want to go or when they want to fly. This is akin to when you fly on an airplane to a hub, but still have to rent a car or hike to your final destination. With Electron, small spacecraft operators can charter a launch to a specific destination in space at the time they want to fly. For payloads up to 225 kilograms, depending on the specific orbit, Electron is the perfect match for a dedicated launch solution. While other small launch vehicles coming to market are offering greater capacity than Electron, smaller spacecraft will have to ride share or buy an expensive, larger vehicle to get exactly where they want to go. Even on an Electron-class launch vehicle, rideshare can still be an attractive option for providing economical launch solutions to small spacecraft, such as CubeSats, similar to today's launch. Rocket Lab is planning rideshare missions to both mid-inclination and sun-synchronous orbits in the coming year to provide individual CubeSats and smaller microsats an opportunity to fly on Electron. In either case, whether you're planning a dedicated launch or rideshare mission, you can contact us via the contact section of our website at rocketlabusa.com. A little bit about the history of the company. Rocket Lab was founded in 2006 by Peter Beck and successfully reached space in 2009 with the ATIA rocket, making Rocket Lab the first private company in the Southern Hemisphere to reach space. Rocket Lab continued on other projects such as VLM, the Viscous Liquid Monopropellant Test Vehicle, and Instant Eyes, a hand-launched rocket-powered unmanned aerial vehicle. In 2014, Rocket Lab officially unveiled the Electron and conducted our first launch, successfully reaching space in May of 2017. Our RocketLabUSA.com website career section currently has a number of positions available in the United States and New Zealand. If you're an enthusiastic and self-motivated individual with 4 or more years of applicable engineering experience, our propulsion manufacturing engineering position in Huntington Beach, California may be of interest to you. We manufacture our Rutherford first and second stage engines in Huntington Beach using advanced additive manufacturing techniques, and experience in manufacturing, test, and final assembly are desired. For those looking for a position in our Auckland facilities with electronics engineering experience, we're currently seeking a talented engineer who would be involved in all aspects of avionics product development, including conceptual design, schematic capture, PCB layout, prototyping, manufacturing, and integration. There are many more positions at all of our sites, and we encourage applicants to apply directly via our website. We're currently approaching 6 minutes prior to launch. We are waiting for the final go based on weather, so we'll stand by and get back with you shortly.
Stage 2 locks pressed.
Pressing gyro.
PLS, confirm anti-gathering is disabled.
Fast purge on.
Stage 1, confirm stage 1 is pressed.
Confirm fast purge on.
We are currently inside 1 minute. At any point, we could still call a manual hold to the launch if required, but we are at 45 seconds and counting.
Control on.
T-minus 35.
Setting TNC states.
T-minus 25.
Jelly John.
Re-readying engines.
Ten, 9, 8, 7, 6, 5, 4, 3, 2.
Ignition. Beginning virtual launch over. Guidance is nominal.
Max dynamic pressure approaching. Max dynamic pressure.
Altitude 20 kilometers.
Past maximum shear, dynamic pressure 50% of maximum.
AOS set Chathams.
30 seconds, stage 1 remaining. CO2.
Stage 1 propulsion still nominal.
Minimize AOA. Burnout detect mode. Staging.
Stage 1 makeup.
Stage 2 startup.
Stage 2 engine ignited. Stage 2 propulsion nominal.
Vehicle is stable.
Following nominal IRP track.
Southland is above horizon, awaiting S-band shutdown and UHF startup.
Fairing separation.
Propulsion remains nominal.
Telemetry nominal at Mahia and Chathams.
As you've been watching, the Electron has completed Stage 1 boost, Stage 2 separation ignition, and fairing deployment. After a little under 5 minutes, Stage 2 will perform a planned shutdown, and the first customer payloads will be deployed. We'll continue to follow the video stream and mission control audio channels until we reach that point in the mission.
Guidance is nominal, speed is 3 kilometers per second.
Propulsion remains nominal.
This is Mission Control Auckland. The flight so far is green, and we're approximately 3 minutes until Stage 2 shutdown, which will be followed shortly by payload deployment. We will continue to follow the burn for as long as we have video. In the event that we do have video but have good telemetry, we'll continue to provide updates over the web stream audio feed, and we'd cut over to Mission Control at that time. Please stand by as we continue to follow Stage 2 burn.
Coming up on hot swap. Hot swapping. Eject.
Propulsion remains nominal.
Velocity 4.6 kilometers per second.
Failsafe is down. Nominally through the gate.
One minute.
As you just heard, there is 1 minute remaining in Stage 2 burn.
Burnout detect. Mode. Twenty seconds remaining.
Velocity 7 kilometers per second.
10 seconds. 5 seconds.
Vehicles orbital.
Engine shut down.
Can confirm IP to the payload destroyer.
This is Mission Control Auckland. As you're watching here on the video stream, we've got confirmation of payload deploy orbit insertion, which wraps up the initial part of our mission with a successful insertion into orbit. Today represents a significant milestone in opening up access to space. to better understand our planet and improve life on Earth. At this point, we're going to end the webcast, so thanks for watching with us today. To stay up to date on future launches, follow Rocket Lab USA on social media or go to our website, rocketlabusa.com. This is Rocket Lab Mission Control, signing off.